అది లేదు ఎవరండి
Good morning, everybody. Hello. Hello. I hope my voice is audible to everyone. Let us wait 1 or 2 minutes to join some other members. All of you, please mute yourself first. Don't try to create any type of the disturbance. Just wait 1 minute to join some other members.
లేదంట వాళ్ళ బయట రమ్మని అయితే మా
Srinivas sir,
సార్ చెప్పండి సార్.
may I start my session, sir?
ఎస్ సార్.
Okay, sir. Okay. Thank you.
సార్ స్క్రీన్ షేరింగ్ ఈజ్ నాట్ విజిబుల్ సార్.
Okay, sir. Okay.
అమ్మా
Please check once now, sir.
ఓకే సార్, ఓకే సార్.
Are you able to?
ఇట్ విజిబుల్ సార్. ఎస్ సార్.
Okay, sir. Okay. Thank you, sir. Okay. Good morning, everybody. Today we are discussing the topic is software architecture in the future. In the last class, we are discussing about.
ఇంకోటి ఏమన్నా?
Good morning, everybody. Okay, in the last class, we are discussing about building systems from off-the-shelf components. So just try to see once what we discussed in the last class in 1 or 2 minutes.
అందుకే అమ్మా ఇంకో ఇయర్ ఫోన్స్ ఉండాలిరా.
All of you mute yourself first. Don't try to create any type of the disturbance. In the last class, we are discussing about the building systems from off-the-shelf components. So what is the purpose of off-the-shelf components are used for to achieving the desired qualities? To achieving the desired qualities. So that means these are used for providing the integration with the some other module. So that means each and every software having more than one module. So now we are providing some integration between them. At the same time, these are used for to verify whether we are meets the desired quality or not. If you are not meet those type of qualities, so the off-the-shelf components are used for to reach the type of the desired qualities. Okay, so in the last class we are discussing about this. If you are observed here, operating systems we are using from 1960s. So we also know what is the use of operating system. So what is the operating system? Operating system is nothing but providing the interface between user and system. So that means before using the operating systems, programmers or maybe the users need to interacting with the hardware directly. So whenever it will be available from the 1960s, then reducing the complexity in front of the developers, at the same time users also. In the same way, when using applications, database is software. Why? Because so easily accessing the software using some interface based upon the number of database applications. So those database applications are interacting by the users easily by providing some other interface. So that means we also know about this when we are doing some project. So it will be consists of two parts, front end and back end. So in the case of front end, so just we are providing user interface, graphical user interface. So we can design the interface which is easily interacted by the user. So that means just only click this button, just next pay this bill. Just if you click this button, next it will be giving the report, and we can select what is the range. So am I right or not? For example, if it is a whatever it may be, so the application, so we can easily performing the operations by the users with the help of DBMS. Okay, because of the ubiquity of computers, the possibility of using externally developed components to achieve some system goals has been increased dramatically. So that means when we are using these features, then increasing the but you need to understand how to operate system. Help the shelf we providing the so involve this to identify assembles of the compatible components, understanding how they attributes and deciding whether they can be integrated into the system being built. So that means the main purpose of consider the off the shelf components are used to provide the understandability at the same time providing the cooperation between the number of modules. Okay, so impact of the components on architecture. So what is a component here? So nothing but that is a module. Consider the following situation: you are producing software to control a chemical plant. For example, if we are controlling the chemical plant by using the some software, then how we are design the software for to control the chemical plant? Just only we are providing different types of the interfaces. For example, if we are click this button, then it will be performing different types of action. If maybe if you are using this button or maybe using this search, we can know the how many number of chemicals are available like this. So in this way, different types of interfaces are designed, so which are easily moved for to the users. Okay. And the next one, the use of the shelf components in software development, while essential in many cases, also introduce new challenges. In particular, component capabilities and liabilities are principal architectural constraints. So when we are developing one software architecture, first of all, we try to, architects may be having the actual goal. So what is the actual goal? So then at the same time, we can able to identify the component capabilities, at the same time liabilities. So these are the main constraints. So by using the off-the-shelf components, so or maybe the OTS, off-the-shelf components, so we are easily reach the desired qualities. For example, if any time of the situation may be occurring the problems, those type of problems are here we are referred as a mismatches. So those type of mismatches are referred to as architectural mismatches. So which type of architecture it is? Software architecture. Am I right or not? So what is the meaning of software architecture? Here we are designing some software according to the some blueprint or maybe the design. So in some type of situations, maybe it will not reach to the exact requirements. So that means maybe the chance of occurring this type of situation is allowing the unauthorized users. So for example, if you are not maintaining the security properly, then maybe the chance of occurring the mismatches frequently. Why? Because if we are allowing unauthorized users, they are try to hack the data, or maybe they are try to, here we are consider two types of intruders here, passive intruders or maybe the active intruders. If it is a passive intruders, no problem, but that is also a one of the security design issue. We don't allow any type of the unauthorized user person to accessing our data without admin permission. Okay, for example, if we are allowing the active intruders, then what will happen? So then maybe the chance of occurring the mismatches. Why? Because they are spoil the actual code, or maybe they are disconnecting some interfaces, and they are providing some ambiguity in front of the users, so which are easily users interacting with the software. Those type of interfaces are spoiled by the hackers. So that type of the situation here we are architectural mismatch. So that means the main cause of occurring the architectural mismatch is if we are not providing the security in the proper way. So that means we will not allow any other in the data. At the same time, we are able to guess how many number of users are using the data and how much of time is used by the user. So that will be also traced by the software. So then only we are easily guess who is the real authorized user and who is the unauthorized user. Okay, so in the case of architectural mismatch, it is a special case of interface mismatch where the interface is defined. It is the assumptions that components can make about each other. This definition goes beyond what was unfortunately becomes the standard concept of interface in a current practice, a component API. For example, maybe any type of the software, so that will be accessed through interface. Am I right or not? Without interface, we are not able to easily accessing any type of the software. For example, without operating system, we are not easily communicating with the system. Am I right or not? So why? Because we are providing the communication between different types of the hardware devices with the help of operating system. So even though CPU configuration is different, and at the same time physical memory configuration is different, and keyboard configuration is different, but we try to providing the communication between three different types of the devices by using the operating system. So in the same way, so if we are not providing exact interface to interaction for the users, then users also not easily communicating with the software. So that's the problem. So in API names, the programs and their parameters and the may something about the behavior, but this is only the small part of the information needed to correctly use this component. So here occurring the problems when we are allowing another users to accessing the data, then occurring these type of problems, those type of problems are here we refer to as a architectural mismatches. Okay, interface mismatch can appear in integration time just like architectural mismatch, but it can also leads to runtime errors mentioned before. So here we are those type of mismatches we can consider it into the three types. So those are how here. So the first thing is how to repair those type of mismatches, how to avoid those type of mismatches, and how to detect those type of mismatches. So techniques for repairing the interface mismatch. Here we are using different types of techniques. So the main technique is nothing but we try to reconstructing the software. So that is the first thing. So whenever occurring the problem in the interface, so then users not easily communicating with the designed software. Am I right or not? So that's why we try to verify each and every module. So whether those type of modules are properly performing the function or not. So otherwise we try to we try to decompose that particular module. At the same time, we are verifying the functionality of the sub modules, whether those type of modules are properly performing the functionalities or not. Otherwise, we try to reconstructing the software. So that means reconstructing that particular module only. Okay. Hello. 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 Okay. I
Sir,
hope I'm audible.
sir, చెప్పండి sir.
Okay. Okay. I think I am audible to everyone. Am I right, sir?
Yes, sir. Yes, sir.
Okay, sir. Thank you. Thank you, sir. Okay. So in the case of techniques for repairing the interface, here we are based upon to the three things here. So those are wrappers, and another one is the here we are using bridges, and another one is the mediator. So these three things are used for to repairing the interface mismatch. So what is the use of wrappers means these are using some other interfaces. So that means which type of interfaces are not performing the properly function with the users. So at that place we are using some other interfaces to accessing the real interfaces by the users. So that type of the situation will be we can possible through using the wrappers. In the same way, bridges are also communicating the providing the communication between the interfaces and the user, and the mediators also the performing the same thing. So that means here whenever occurring the problem, we are not achieving such availability means users able to freely interacting with the software at the same time performing their functions. Okay, in the same way, here techniques for detecting the interface mismatch. So that means here we try to identify the functionality of the each and every module and every time. So whenever those type of interfaces are not satisfying the user requirements, then we are easily observe so the interface mismatch is occurred. So we try to recover that mismatch. So when we are detecting whenever it is detected by the architect or maybe the developers. In the same way, techniques for avoiding the interface mismatches, these are the main design issues to avoiding the interface mismatch. So that means here when we are designing some software architecture based upon the design only we are performing the implementation. Am I right or not? So at this time of situation here we are clearly verify and performing the testing clearly. So whether the type of the interface mismatch is occurred or not in the future. So that will be easily verified if the design is properly. If the design is correct, then we are try to avoid those type of mismatches occurred in the future. Okay, and another thing, after before delivering the software to the end users, we try to performing the evaluation efficiently. So otherwise maybe the chance of occurring these type of situations. And the second thing is component based design as such. We already discussed all these points in the last class. Just try to revise all these things. So here we are component based design as such. So here we are designing the components. So that means how we are designing the modules. So before developing any type of the software architects, so they are having different types of the steps to design the software. We also know about that. So initially gathering some requirements, next design, next coding, next implementation, next evaluation, next receiving the feedback from the user, next to try to correct that type of the software until the satisfaction from the until we are receiving the satisfaction from the user. Okay, the same type of the procedure is followed here. So here, since the component capabilities and liabilities are principal source of architectural constraint in the system development, and since systems use multiple components, component based system design becomes as such for compatible ensembles of the shelf. These are hello. Hello. If you are
sir.
not if you are not designing these modules in the efficient type of it, then occurring the problems. So that means these are based upon to reach the our specific objectives. So the architects must determine if it is feasible to integrate the components in each ensemble, and in particular to evaluate whether the ensemble can live in the architecture to support the system requirements. So that means before start any type of the any type of the software, first of all we try to performing the feasibility study. So we also know about this. What is the meaning, what is the use of feasibility study means before starting that particular software designing or maybe the project. Okay, please give me 1 minute. Srino sir,
సార్ చెప్పండి.
just you continue 1 minute sir.
ఓకే ఓకే.
ఫోన్ ఆడ దగ్గర ఉందా, తీయండి ఫోన్. హలో.
చెప్పండి సార్.
Okay sir, okay, thank you. So that means when we are developing components, so we try to perform the evaluation efficiently. In the case of component based design search, here also we are using different types of the steps to designing the these type of components. So that means initially architects, well, first of all verifying which type of things are required. So that means architects should be designing the software according to the desired requirements or maybe the desired goals. Then we try to performing the evaluation, so whether it is meets the user requirements or not. Otherwise we try to repeat the same procedure until we are receiving the desired requirements from this design software. Okay, so the first step is the architect first and add the engineers identify the design question. The design question initiates model problem referring to an unknown that expressed a hypothesis. So that means before designing any type of the software, the architects must be having the goal. So actual goal, what is the actual goal, what is to be achieved. So that type of idea should be having the architect. The second thing is the architect, the engineers define the starting evaluation criteria. This criteria describe how the model solution will support the contradict the hypothesis. So that means here verifying the solution, so which is we are able to receive after developing the software architecture. So then we can performing the evaluation whether it is suitable to release it to the end user or not. So the architect and the engineers define the implementation constraints. So here we are implementing the software with the some particular constraints. Maybe those type of constraints are related with the different types of things. Those are maybe related with the quality attributes, business attributes, architectural attributes. So next, the engineers produce model solution. So this model solution is a minimal application that uses only the features of component. So in the fifth step, the engineers identify the ending evaluation criteria. Ending evaluation criteria include starting set plus criteria that are the discovered by the product implementing the model solution. So the last step is the architecture performs the evaluation of the model solution. So again, it's the ending criteria. So that means if you are observing in this diagram, so the first step is pre-ensemble defined. So architect and engineers define the models problem. So that means what is the problem, what is to be achieved, which type of things are needed, and defining the criteria, and define hypothesis, define constraints. So that means here we are performing the requirement analysis phase, and at the same time architects may be having the clear idea about the goal. So that means what to be achieved. So that is the first step. So next, they are defining a model solution. So that means they are giving some solution according to the collecting requirements and performing the implementation. Next, they are able to design giving some solution. Now that solution is verified. So evaluation is performed in the third step. So that means whatever it may be, we are considering in the previous case 6 steps. Those are here mentioned into the only 3 steps. The first one is define the model problem. Second thing, define the model solution. And third one is evaluating the solution. So if it is correct, then we can releasing the software to the end users. So this is the way to design the components. So we also know about this. So in the previous case, just we have mentioned requirement analysis, design, coding, testing, implementation. So here just they are expressed in the 3 steps only. First of all, we try to define the model problem. So that means what is the problem and what to be required to achieve that type of the quality, and what define hypothesis. Okay, so all these things are specified in the first step. Second step, they are giving some solution. Third step, evaluating the solution. Okay, in the last class, we are consider the SLIM examples also. So SLIM example means Software Engineering Institute. So SLIM means Automated Software Engineering Institute License Management. So how this will be works. Okay, so when we are designing this type of SLIM software, for example, so in this software here we try to identify the administrator, and we are giving some responsibility to the administrator, assigning some courses to the students, and assigning some course instructors, and they are giving the deliver to the course to the students, and how many number of students are present in that particular session. So all these are verified in the SLIM software. So all these things are we are discussed in the last class. When we are discussing about when we are consider the above software, then we are verifying some quality attributes like maybe the performance, functionality, compatibility, security. All these things are verified. So we also know about different types of the quality attributes. So those are maybe portability and interoperability and performance, functionality, okay, throughput. So all these things are the quality attributes where should be verified, all these attributes. Why? Because if you are not performing the evaluation properly, then maybe the chance of occurring the architecture mismatches, then we need to reconstruct again. So then it will be leads to lot of time. At the same time, it will be leads to lot of the time, at the same time lot of money also. So that means automatically it is the out of the scope. So before developing any type of the software architecture, we should be having the clear idea about the components design. So why? Because here the components means nothing but those are the modules. So if these modules are properly functioned, so then only we try to performing the then only we try to releasing the software to the end users. Otherwise occurring the architecture mismatch interfaces. Why? Because those type of mismatches are occurred through allowing the unauthorized users to access the data. Am I right or not? So now we're discussing the actual topic today. So that is software architecture in the future. I think the name is in place. So here, in which type of way we are using the software architecture in the future. So up to now we are discussing the just only one system to many, and building the systems from the off-the-shelf components. Now we are discussing the last topic of the second unit, that is software architecture in the future. The history of the programming can be viewed as a succession of ever increasing the facilities expressing the complex functionality. In the beginning, assembly language offered the most elementary of the abstractions, exactly where in physical memory things resided, and the machine code necessary to perform the primitive arithmetic and move operations. We also know about in the previous cases how the software will be performing the arithmetic operations, or maybe the some particular computations. We also know about this. So how we are designing the software, at the same time how it will be providing the communication between the software and the hardware. And another thing, in the previous cases, in the starting stage, we are based upon to the assembly language. So that type of the assembly language is used for increasing the speed. At the same time, it will be reducing the time to performing the computation. For example, in the previous case, we are using the compilers. So those type of compilers are used for to converting from machine level language to high level language, at the same time high level language to the low level language. So when we are using assembly level language, it will be reducing the time to performing the compilation, then automatically increasing the speed, at the same time automatically increasing the throughput. At the same time, we also studied in the CO, computer organization. So we are studying about different types of registers. So whenever instruction register is loaded with the particular instruction, then it will be performing the execution, and we are using different types of the registers, maybe like as a program counter, program status word, MER, memory address register, memory buffer register, and another thing, here we are using different types of registers, like maybe the data register, so and another one address register, so like this. So here in the case of life cycle, we also know about the instruction cycle also. So in that type of the instruction cycle, we are using four types of steps. So what are they? Fetching the instruction, and loading the instruction, next decoding the instruction, and next executing the instruction. Here some of the, hello, all of you please mute yourself first. Some of the members voice is raised in this session. Hello, Srinivas sir.
చెప్పండి సార్ చెప్పండి సార్
Who is number 95? I think Sombabu. Sombabu,
yes sir
please mute yourself first. 62. Please mute yourself. Don't try to create any type of the disturbance. Most of the members not using mute. Please try to check once. Sir, you send the message personally to their number, sir. Otherwise, you put the option to them.
ఓకే
sir.
ఓకే సార్ ఓకే
Thank you, sir. Okay. In the previous sessions, in the previous days, we are based upon to the reset the memory, and we are executing the instruction one by one. Am I right or not? So that means at this time of situation here, we are using these type of the things. So even in this the primitive environment, programs exhibited architectures. Elements were blocks of the code connected by the physical proximity, or one to another, are knitted together by branching statements, or perhaps subroutines whose connectors were branch and return and constructions. We also know about this. So when we are executing the instructions according to the instruction cycle, we are first of all, we try to fetch our required instruction from the memory, and that will be loaded into the uh, uh, instruction register. So after performing the instruction register execution, so that means here we are following the instruction cycle 4 steps. So first of all, we try to fetch the required instruction from the memory. That is possible through using the program counter. Okay, so that means before fetching that instruction, we should be load the address register into the PC. So what is the purpose of PC? So what is the next instruction to be executed by to the CPU will be decided by to the program counter. So next we are loading the instruction into the instruction register. Next we are performing the decoding. After decoding, next we are performing the execution. So after then we are executing another instruction. So that means in this type of way we are using some type of the cycle to executing the instructions. Early programming languages initialization these constructs with the connectors being semicolon, the go-to statement, and the parameterizer function call. So in the case of C language, or maybe CPP, or maybe the Java, so here we are using some type of the terminology. So every ending statement, every statement should be ending with the semicolon, and we are using some different types of the features, like maybe the go-to statement, and at the same time we are using some parameter, some using some functions to performing the computation. So that means in the previous case, we are how we are executing the instructions, and at the same time how we are performing the computations. In the starting stage, we are executing one by one instruction. Next, we are using some type of the programming languages. So in the, so and we are using some subroutines also. We also know about subroutine. So what is the subroutine here? After performing the some operation, we are storing the result into the subroutine register. Then that will be used for to performing the some other computation. So the architecture business cycle register. In this context, we can now identify and discuss different types of the categories of the different types of versions of the different types of versions of the programming languages, at the same time different types of architectures to performing the computations. So now we are consider the four types of ABC. So what is the ABC here? So ABC means architecture business cycle. Okay, so here we are consider four types of versions. So these types of four types of versions are also used in the architecture business cycle. So the first one is the simplest case in which a single organization creates single architecture for a single system. So that means in the first simplest case in which single organization creates single architecture for a single system. So that means here we are using single system, single architecture, and using single organization. What is a single organization means? Which is using that software. So that organization is nothing but single organization and creates the single architecture for a single system. And in the second case, one in which a business creates not just a single system from an architecture, but an entire product line of system that are related a common architecture and a common asset base. So that means here we are using more than one systems, but they are based upon the common architecture to achieve the desired goal. And the third thing is one in which through community-wide effort, a standard architecture or reference architecture is created from which is large number of systems flow. So that means here we are using distributed operating systems. So in the first case here we are using multi-programming operating system. What is a multi-programming operating system? Here only single CPU is responsible for to executing the more number of instructions simultaneously. Am I right or not? In the same way, in the second case here, we are using parallel operating system. So that means more than one CPU can able to performing the instructions execution, but based upon to the shared memory. But in the case third case, here we are using distributed operating system. So that means here we are allocating the different types of distributed memory. So that means we are allocating individual memories to the CPUs to performing the execution, then automatically increasing the throughput. In the last case, one in which the architecture becomes so persuasive, the developing organization effectively becomes the world, as in the case of World Wide Web. So that means here we are based upon to the real-time operating system. So and we are using more number of systems, and here the storage is also based upon to the cloud. So in this type of here we are increasing our productivity, and we are performing different types of the modifications in a architecture, software architecture, and we are performing different types of computations, and we are performing some modifications in a computations. So in the case of initial stage, we are executing one by one. Next, we are based upon to the residing some memory, storing some instructions inside. And next, we are using some subroutine register. Next, we are using different types of operating systems, or maybe the multi-programming operating system, or parallel operating system, distributed operating system, real-time operating system. Okay, so in this type of different types of modifications in a software architecture, creating an architecture, we emphasize the quality requirements for the system being built, tactics used by the architect, and how these tactics were the manifested in the architecture. So that means how we are creating the architecture. So what is the best way to creating the architecture? Which type of architecture is here? We are created software architecture. So what is the meaning of software? To solving the some problem, reducing the complexity that problem by using the system. Okay, so that will be referred as a nothing but a software here. So that means how we are designing the, or how we are creating the architecture. At this process of moving from quality requirements to architectural designs remains an area where much fruitful research can be done. So that means here we are some type of the allowing some research to creating the architecture. Here that means here we are consider some design issues. Those type of design issues are used for to creating the architecture in the efficient type of way. So which type of things are here we are considered? So the first thing here we are answering some of the questions. So those type of questions will be improving the design process. So any type of the software quality, is based upon to the always based upon to the design, because according to the design only we are performing the coding, at the same time implementation. Am I right or not? So that means if the design is different, then we can try to implement in another type of way. Okay, so that means any type of the software designing, if the software quality is based upon to the software design only. Okay, here we are arranging some issues or maybe some designing issues, or maybe we are try to giving the answers for the following questions. The first question is, are the lists of the quality attribute scenarios and tactics to be tactics complete? So that means here we are whether we are able to identify the quality attribute scenarios and tactics complete. So that means what is the meaning of tactics? Tactics means strategies. Okay, here before designing any type of the software architecture, first of all we try to identify so which type of quality attributes are should be included into the design this developed software architecture. So that means so we also know about different types of qualities. So system qualities and attribute qualities, and another one is the business qualities. In the case of system qualities, we are considered different types of the things like maybe the performance, security, throughput, reliability, operability, and another one is the modifiability and portability. Like these different types of attributes that we are considered. If we are maintaining all these attributes in the proper way, so then automatically it will be having the highest rating in the marketing. Am I right or not? So that's why first of all we try to verify whether we are able to list out the all quality attributes and tactics to be complete. So that means which type of strategies are used to achieve those type of qualities. So whether it is complete or not. So first of all, we try to verifying this first thing, and second thing, how are the scenarios and tactics coupled? So that means whatever it may be, we are having the design issues, and whatever it may be, we are using the strategies. How we are using this? So whether we are using in the proper way or not. So these type of strategies are really achieve the our desired qualities or not. So that thing, those type of things are here verified. And how can the results applying tactics to be predicted? So that means so before applying any type of the technique, so we should be able to perform in the prediction. So that means, for example, if this if we are using this strategy, or maybe if we are using this tactic, so then whether we are able to reach that type of quality or not. So before applying that, we are able to guess what will be happen next. So that type of the prediction will be also done. And the fourth thing, how are the tactics combined into the patterns? So here these tactics you are use it for to designing the patterns. So that means those are maybe like maybe the design the modules. What kind of tool support can assist in the design process? So that means in this type of we are performing the testing. Can tactics go into the system? So that means these strategies are applied in the software designing in the proper way or not. So that means here when we are creating architecture, so we are verifying all these things. So then we are able to design the good quality of the software architecture. Okay, next is the architecture within the life cycle. Okay, although we have argued that the architecture is the central artifact within the life cycle, the fact remains that life cycle for a particular system comprises for more than architecture development. We see several areas for research architecture within the life cycle. So that means, so in the architecture within the life cycle, so that means, so what is the architecture life cycle here? So initially we are gathering some requirement. Next we are performing design. Next, according to the design, we are performing the implementation. Next, we are releasing that software to the end users. Next, we receive some feedback from the customers or maybe the end users. Based upon the customers' feedback, also we are trying to performing some modifications. So this procedure is repeated until we are achieve our desired qualities. Am I right or not? So in the same way, so in the architecture within the life cycle, mainly consider the three things. So those are the first thing is documentation within a tool environment. The second thing is software architecture within the configuration management systems. And third thing is moving from the architecture to the code. So these three things are main when we are designing some architecture. So or maybe when we are releasing some software to the end users. So documentation within a tool environment. So that means here we are providing the proper documentation for to the end users. So that means when we are releasing some software to the end users, then we are reducing the interaction with the software developer or maybe the software architect with the user through providing the proper documentation. So otherwise, each and every time, maybe the may not be having the chance to communicating with the architect every time for the users. So at this time of situation, this documentation will be used for recover the errors by the user's knowledge. So that means if you are using this button and if you are using these types of steps, then you automatically recover its problems and which type of problems are occurred during the session, and how the those type of problems are faced by the users. All these are maintained into the documentation, and we try to maintain the consistency also. So if you are not maintain the exact data in the documentation, then it will be also create the lot of the problems. And second thing is software architecture within the configuration management system. So that means here we are using some management system. So that means here we are properly maintained the software. So that means, so here we are verifying different types of the attributes. So maybe like maybe the performance, what in which type of those type of modules are performed. And here in some type of situations we are verifying the sub modules also. So those type of modules are performing the properly functioned or not. So all these things are we are properly verified here. And the third one is moving from the architecture to code. So in these three types of design issues, we are mainly maintaining the one type of the property. So that is nothing but consistency. Why? Because if you are not maintaining the consistency clearly, so then occurring the problems. So that means here, so the documentation is important. At the same time, and another thing is here we are architecture to code. So that means in some type of situations occurring the problems. So at that time of the situation, we try to performing the reconstructing the software architecture. So that means here architecture to code, at the same time repeating the same types of the steps to achieving our desired qualities. Okay. And another thing is the impact of commercial components. The capabilities and availability of the commercial components are growing rapidly. So here when we are designing some software, then it will be giving some impact onto the some other things. So those are maybe the capabilities and the availability of the commercial components growing rapidly. So two are the availability of domain specific architectures and frameworks to support them. So the day is coming when the domain specific architectures and frameworks will be available for many of today's common domains. As a result, architects will be concerned as much with constraints caused by the chosen framework by greenfield design. So not even the availability of components with the extensive functionality will free architects from the problems of design. However, the first thing the architect must do is determine the properties of the user components. So components reflect the architectural assumptions, and it becomes the job of the architects to identify them, assess their impact on the systems being designed. So that means here when we are designing some software, then it will be giving some impact onto the some other issues also. So those type of issues are some of them are related with the financial, and some of them are related with the availability, and another one is the compatibility, like this. Okay. Next, another one is the components reflect architectural assumptions, and it becomes the job of the architects to identify them and assess their impact on the system being designed. So that means here the architects should be identified whether those type of modules are properly performed or not. So whether those type of components are achieving the desired goals or not. So all these things are clearly verified. So and these are we are already discussed in the architecture business cycle. So when we are releasing some software to the end users, then it will be giving different types of influences to the uh, to the some of the things. So those are nothing but the first one is the stakeholders and business organization and software architects and maybe the engineers knowledge also. So or maybe sorry technical knowledge also. So here these type of things are impact or maybe influenced after we are designing the software. And if you are not mentioned,
Hmm.
if you are not take care about the quality attributes clearly, then also occurring the problems. Am I right or not? So that means, so before releasing any type of the software, first of all, we try to identify whether we are maintaining the quality attributes in the proper way or not. So otherwise, maybe the chance of occurring the architectural mismatches. So those type of mismatches are we are recovered through using different types of the techniques, maybe like using the bridges or maybe the wrappers or maybe the mediators. So and another thing is here when we are designing the components and we are based
Huh?
upon to the different types of the steps. So those types of
సార్
steps
జాతీయాలు
are,
డబ్బులు ఉన్నాయా?
those types of steps are used for reducing the occurrences of the
ఎవరు
mismatches in the
పెట్టుకో
architecture. Okay.
అట్లా
Determination of the quality characteristics of the components and associated framework is important design using externally constructed through components. So how will the architect know the effect of options the framework provides, and even more difficult qualities achieved when architects
తిప్పు
has
తిప్పు
no. We need a method of enumerating the
ఏమో చూద్దాం.
architectural dimensions of
శాలరీ
components
పడిందంటే
and understanding the concepts of the
5,000 పడినాయా?
finally components and their associated frameworks must be produced and production must be designed to achieve desired qualities. So that means here the main thing is main step of the in the designing of the software architecture is testing. So otherwise it will be leads to a lot of problems. Why? Because if you are not performing the testing in the proper way, or maybe if you are not performing the evaluation in the proper way, then it will be needs to create a lot of problems. Maybe those type of problems leads to increasing the time and increasing the numbers at the same time
ఏమో అగ్గేస్తుందండి బాబా.
and it will be the out of the scope. So when we are designing or creating architecture, we should be following all these steps. So these are the important factors when we are designing the software. So up to now we are discussing about in the part 2 here we are discussing the 3 topics. So those are nothing but the first from moving from one system to many. So that means when we are increasing the productivity, so then definitely we are using the product lines. So these type of product lines are used for increasing the throughput. So that's why we are moving from one system to many. So that will be possible through using software product lines. And another one, building the systems from the off the shelf components. And third one, software architecture in the future. So these 3 things are used for moving from one system to many. So that means when we are increasing our throughput, we should be verifying all these things. So in the case of product lines, or maybe the off-the-shelf components, or maybe the software architecture in the future. Okay. Today we are ending this topic of the second unit. So completing the second unit up to now. So if you having any type of the doubts, you can ask me. If you're having any type of the doubts, please ask me. And I try to say another thing. So that is, I'm giving the assignment to all members, and based upon this assignment also, I'm giving some marks. So please try to submit the assignment after the completion of every unit. So in the same way, you can submit the second assignment also. So that is, so up to now we are discussing the 6 topics. Sorry, 6 topics. Yes, 6 topics we are discussed in the second unit. You try to giving us some summary about these 6 topics. So those type of 6 topics are in the case of analyzing architectures. What is the purpose of using the architecture evaluation? What are the main steps to performing the evaluation? And another one, what is ADM? What are the main steps? What is CBM? What are the main steps? In the same way, what is a software product lines, and what is the purpose? So what is the purpose of off-the-shelf components, and what is the purpose of how we are creating the architectures in the futures? So these 6 topics you should be giving the summary about these 6 topics and submitting the assignment within next week. Try to submit the assignment within the next week. So what's the date today? I think today 8th. So you can submit the assignment after 10 days before 18. Okay, you try to submit this assignment. Why I am giving this assignment to you is nothing but you try to practice this subject. And another thing, I'm alerting the marks for you submitting the assignment. Okay, and I'm not giving the additional assignment, any additional assignment regarding the marks. Okay, just only I'm considering these 3 assignments. So first unit 1 assignment, second unit 1 assignment, and third unit is the another assignment. So now we are completing the second unit. So you try to submit the second assignment and you give the just a summary. What is the architecture evaluation? What is a architecture? What is ADM? What is CVM? what is the purpose of software product lines. So what is the purpose of building systems from the off the shelf components. So what is a software architecture in the future. So just you try to give the summary about these 6 topics. So maybe these are helpful for in the exam point of view. So that's why I'm giving the assignment. You don't try to feel it is a burden, and don't try to feel it is a headache. Okay, if it is a actual class, I'm conducting test after the completion of every unit. So that's why I'm giving this assignment to you. So please don't try to feel about this, and submit the assignment before the 18th September. Okay, thank you one and all. Thank you everyone. Srinivas sir. Okay, thank you.